Hi everyone, today we are going to look into the basics of assembly modeling. After this, we'll see how to incorporate these basic assembly modeling techniques into making the product given in your problem statement. So, without much ado, let's get started. So for this purpose, we are going to take a hollow cylinder, simply drew two concentric circles, extruded them out, then took the front plane and cut out these holes. I'm going to take this and to show the motion between two objects, I'm going to take the same body. I'm going to look for the move or copy command. I'm going to create a copy of this body. Now that I have created a copy of the body, I'm going to use something called as the joins to show relevant mating capabilities between these two parts. Before we do that, we have to understand how Fusion 360 does mating between these objects. For that, first, there's something called as creating a component from a body. There are multiple ways to create it. You can click on your body, right click, and create component from bodies, or you can go to assemble, click on new component and select the body. Personally, find the easiest way to be creating components from the body. Now that we have two components, you will notice that the symbols have changed and the component itself houses a body. This happens to be the primary difference between a body and a component. While a body can be used as a physical representation, a visual representation, it is not in itself enough to describe different mechanisms or different assemblies between two different bodies. This is when the whole idea of component comes into picture. As you can also see, components have their own origin planes, unlike bodies which have a single origin plane over here. So next that we're going to look at is something called as joints and assemblies. Also, you can see that you can create by a shortcut called as J. You can also use as built-in joints. That is when you build a component as a part, as a fully rigid part, and then you go about and divide the object to give different motions to different parts of the body. This is something you will see in the utility knife of the Fusion 360. It's already inbuilt. So what you'll notice here is while this is built as one body, these joints drive each other. Uh, um, in spite of them having been given a rigid command, as in this was first built and extruded onto this surface. So this is something that is done by using the as built joint command. It's pretty similar to the joint command we're going to use. So we're going to look at that. So I'm going to use the shortcut J. Since they're already in component, I'm going to create the shortcut J. Now, the question to ask yourself is, which are the two mating features over here? For me, it is this face right here and this face right here. All right. Now you can see that it can move in multiple directions. I do not want that. Now I want this motion to be somewhat linear. So I control the motion by going to something called as motion. I'm going to click on rigid. They are joined to each other. If one moves, the other is also going to move. If I'm going to click on revolute, the top cylinder, because this is a mated cylinder, this is the original cylinder as per our selections. I selected the plane of this first and then I selected this. So what will happen then? It will rotate. Now you can choose about which axis it you wanted to rotate for a revolute joint. You'll also notice that some of your couplings that we make is nothing but two revolute joints. Instead of two cylinders, it might have a Y-shaped body over here, and you might have a revolute joint in between. You can also custom an axis. You can draw an axis using the construct plane, construct an axis. You can use one of these commands and build a plane. Next thing to look at is a slider motion. You will have to select the direction in which you want it to slide. Say you select this direction for it to slide. Well, it will move about the x-axis or the y-axis This is more of a translational motion, as you can very much see. Cylindrical joint, although very similar to your revolute joint, cylindrical joint rotates and also moves about a plane that you choose, or you can customize that by selecting a plane for it to move. Suppose you want to move about this phase. It's rotating in the y-axis but moving in the z-axis. So you could customize the plane that you want to choose for cylindrical axis. A pin slot is a little different from cylindrical axis. It has one translation and one rotational movement, but you can see that the rotation is slightly different from the way a cylindrical joint rotates. Next we see is a planar joint. And a ball joint. This, you give two axes to it. One is a pitch and one is a yaw. Today it's about that, or you could swap that for, say, choose this plane. So the rotation axis has now changed. So these are the different types of joints in assembly modeling. We will use these to build some parts of your problem set. See you in the next video.